I'll post at least the part where we go over the slides will be posted on YouTube here, and I'm still kind of figuring out how I'm going to handle videos. But here we go. Bit is a single digit, and a bit is going to be a 0 or 1, and a byte is a collection of zeros or 1. 8 bits typically equal 1 byte. In a byte, each position refers to some power, which is specifically 2 to the n. Now that's, I've got that as 2 times n, that should be 2 to the n. In a byte, the 0 indicates on or off. So for each position, 1 is on and 0 is off. So let's consider an 8-bit byte. I'm going to go back to this view and I'm going to get out my pen. And here we go. So an 8-bit byte is something that looks like this. And now that's 8-bit. Let me circle that again. I'm still learning to use this live. That's an 8-bit byte. And if you have a 64-bit computer, it's made up of 64 of these, or a 128-bit computer. Okay, so that's a lot of ones and zeros. The way that you read this is you start on the right side. Start on the right side and read right to left. So this is like Hebrew, not English. For those of you that don't know that there are languages that actually read right to left. Okay. The first thing we're looking at is, now the position matters. This is position 1 of 8. This is position 2 of 8 over here. 3, 4, and 5. Okay? You guys get that, hopefully? I'm at 1 of 8. This position corresponds to 2 to the 0, which is actually the number 1. 2 to the 0 is the number 1. And the 1 tells me that that position is turned on. Okay? Next thing I'm going to do, I'm going to look at this position. This 0 in the second position corresponds to 2 to the 1 power, which is 2. But I have a 0 so that I know that this is 0. It means it's turned off. Here's 2 to the 2, 2 to the 3, which corresponds to 2 to the 3, or 8. And again, this number tells me, is that number turned on? So if I wanted to look at this, I can say I have 2 to the 0, the number 1, and that's turned on. I love this pen. So 1 is good. 2 to the 1 is 2, but that's turned off. How do I know? It's a 0. So instead of keeping it, okay, 1, this position, okay, even though it's a 0 or 1, I have to know which position I'm at. This is 2 to the second power, or 4. That's turned on. I keep it. This one I keep. It's 2 to the third. It's the number 8. I'm going to keep it. 16. What that? Can you guys still hear me?
Yes.
Okay, great.
Yes.
Yep.
2 to the 4 is
Yes.
on, and 2 to the 5th is off. So 32 is off. 2 to the 6 is 64. That's on. And 2 to the 7th is 128. That's turned on. Okay. So my numbers are 128 plus, this one actually should have been, oh, that's supposed to be 0. Let me change that real quick. Based on this number up here. Okay. So that should have been off. Okay. So 128 was on, 64 was off, 32 was off, 16 was on, 8 was on, 4 was on, 2 was off, and 1 was on. If I add up the numbers then that are turned on in the circles, okay, that turns out to be the number 157 down here. So this number here represents the number 157. There's a very good video about binary. It's embedded in the notes, and I'll ask you to watch that, but you don't have to do that right now. Just know that on the midterm, you will, can you guys tell how much I love this pen? I use it every chance I get. You will be asked to convert numbers from binary to decimals and vice versa, but you will not be asked to add binary numbers. That's beyond what we're doing here. Now, if you're in computer science, you better know how to add up binary numbers, and you better know what all that means, but you're not asked to do that, okay? And once I have a number now, the question was, how do I turn these numbers? Somebody else said, I said, so what do you do with the number? Well, you get together with your friends and you say, oh, get my pen upside down. Hey, when I send you the number 1, right, which would look like 0, 0, 0, 0, 0, 0, 0, 1, that corresponds to everything else is turned off, and this one is 2 to the 0, which equals 1, and that's turned on. If I just send you 1, I'm actually trying to send you a capital A. If I send you a 2, I'm sending you a capital B. If I'm sending you a 3, I'm sending you a capital C. If I send you the number 27, that's a lowercase a. If I send you 28, I'm sending you a lowercase b. And if I send you a 53, I'm not sending you a letter, I'm sending you a period. If I send you 54, I'm sending you a comma. You can go through, and so we both have to have this mapping of, when you send me a letter, what symbol does that correspond to? But as long as we're both operating off the same key, using 1s and 0s, I can send you any series of numbers that I want. So my name would be 10, 15, 5. 10, J, O, E. J is the 10th letter of the alphabet. O is the 15th letter. E is the 5th letter. 0, 1, 0, 1, 0, 1, 0. Let's pretend I gave you this in binary and I said I want to know what that is. Well, this corresponds to 2 to the 0, which is actually the number 1. Okay? This is 2 to the first, which is the number 2. 2 to the 2, which is 4. 2 to the 3, which is 8. 2 to the 4, 16. 2 to the 5, 32. 2 to the 6, 64. And 2 to the 7, 128. And they're all read as columns like this. Do you understand what I'm doing there? All right.
Yeah.
You get the idea. Now I go through, I say this position was equal to 2 to the 0, but it's turned off. It's a 0. So I'm not going to include that in my final calculation. This one's turned on. I'm going to keep it. The 4 is turned on or off. It's a 0. It's turned off. Okay. The 8 is turned on. Okay. So I'm going to keep that. 16 is turned off. Okay. 32 is turned. 64 is turned
on.
Okay. Now I come over here and I say I want to add up the numbers that were kept on. Okay. So 128 plus 32 is 160. Plus 8 is 168. Plus 2 is 170. So this number 10101010 is equal to 170. Fair? YouTube, but these are things that would be on the test. So CPU, the main parts of the arithmetic logic unit and control unit. So if I'm talking about, let me grab my thing again. This point of this slide, let me help you guys out. The test question here sounds like what? Give me, this is where A students are good. This is what A students are good at. Okay? They look at this and they say, what's that test question going to look like? And what's the test question sound like based on this point of information right here? What are the two main parts of the CPU?
What are the main parts of the
CPU? Front of your flashcard, and the back says what? Right, that's one great way to ask that question.
Arithmetic logic unit and control unit.
What are the two parts of the CPU? What's another version of that question?
Could you say like the arithmetic logical unit and control unit are parts of what?
Compose what, or compose the blank, and then the blank has CPU, and look, it's going to be CPU, and what are your other options going to be? Right?
Not a lot.
Central processing unit.
Northridge and Southridge.
GP.
I mean, you could throw in GPU.
I could say GPA, right? This one and this one.
Yeah.
Well, this one's really deadly, right? If I could draw a little, the skull and crossbones here, right? I'd do it. Why is CUP so deadly? It's the same numbers, they're just in a different order, right? If you just browse the chapter and you say, yeah, I get it, and then you're in a test, you're saying, oh crap, you know, yeah, this, I know is this central unit processing, yeah, okay, this looks good. And GPU sounds just like CPU. Those are dangerous, those are deadly, right? Is GPA, does that, you've heard that term, and if you're not real sharp, you might say, yeah, that's a term I've heard. It must be this one. And then there's pizza and spaghetti, which are going to be what? Dog and has, right? You know, if you even read if you even skim the chapter, you know it's not one of these. Those are just thrown there. So typically I've got the answer. I've got that red herring or two. And then I've got my pizza and spaghetti answers on a test. An operating system determines how the computer will interact with its environment, and an application software is software that actually does the work. Key thing about operating systems, they coordinate applications as well as the interactions between the applications and the input and output devices, or basically they coordinate between software and hardware. That's one of the main things of the operating system. But for those of you who are thinking about, you know, how did Bill Gates get to be a billionaire? Well, he made sure that Word and Excel were seamless, and all you had to do if you wanted to copy a table from Excel into Word, that was pretty easy, because why? He also wrote an operating system that both of those applications ran on. It was really easy for him. He knew every single line of code in that operating system. If you were anybody else and you're trying to make apps that run smoothly on Windows, or at the time, does anybody know what it was called? Started with a D. DOS, right? DOS. And it wasn't, there weren't Windows, it was all command line.
DOS.
But if you wanted to open up those two and copy and paste between them, you could do that. Why? They were initially designed from the minute the first line of code is written to interact with one another.